Hello everyone, welcome to your 8-4 lesson on modeling with quadratic functions. Our learning target for this lesson, we're going to use quadratic functions to model real-world situations. We're going to use quadratic functions that are fitted to data to model real-world situations. We'll use the vertical motion model to write an equation, and then we'll also be able to compare a model to a data set by analyzing and evaluating residuals. All right, so some vocab to fill in. Some of this, probably most of it, will not make sense until we go through some examples, but then when you reference back to this vocab, it'll be more familiar. So a residual is equal to the data value minus the predicted value. And then just a couple notes on that. The data value, this is from recorded data. And the predicted value comes from a function. All right, our next vocab is quadratic regression. This is a method used to find the quadratic function that best fits a data set. So let's write that in together. A method used to find the quadratic function that best fits a data set. And then we can just make a side note on this. We'll be using a graphing calculator to do a quadratic regression. All right, then we have this thing called vertical motion model. So our vertical motion model is a function, h of t equals negative 16t squared plus, we have a v with a subscript of a 0 times t plus an h with a subscript of 0. All right, so let's make some notes on what this is about. This function gives the height of an object after t seconds. Actually, this function gives the height of an object, launched into the air. After t seconds. And then you may have noticed we have some things within this function that we have not seen before. So this v with a subscript of 0, we call that initial velocity. So in the function, our initial velocity, that's a number, gets multiplied by your time. And then this h with a subscript of 0, that is the initial height. So if we were looking at this, this function, we would say the height of an object launched into the air after t seconds is equal to negative 16 times t squared, remember t is your number of seconds, plus the initial velocity times multiplied by your time, plus the initial height. So that's what the v0 and the h0 stand for.